Let's look at some rational equations and other types of equations and applications. So we want to go ahead and solve our equation 2x minus 3 divided by 2 plus 5x divided by x plus 1 equal to x. First things first, find your least common denominator. So our least common denominator is going to be equal to a 2 times x plus 1. And we want to set that equal to 0 to figure out what that x is going to be. So we'll have a 2x plus 2 is equal to 0. Subtract your 2, and you're left with 2x is equal to negative 2, or x is equal to negative 1. So we don't want our x equal to negative 1 because that will end up with a 0 in the bottom, and we don't want that. So now that we have our least common denominator and we know which excluded solutions are, we can go ahead and multiply the tops by the least common denominator and see if anything will cancel out. So we'll have 2x minus 3, and then we'll go ahead and multiply by 2 times x plus 1 divided by 2. And then we'll go ahead and add 2 times x plus 1 multiplied by 5x. Then divide that by x plus 1. And then last we will have we will have an x, and then that will be multiplied by the 2 times x plus 1. So go ahead and see what will cancel out. In our first ones, we can go ahead and cancel out these 2's. Second part, we can cancel out the x plus 1, and then we'll leave the last part. So simplifying, we are left with 2x minus 3, and that will be multiplied by an x plus 1, and then we will have plus 10x, and this will be equal to an x times a 2 times an x plus 1. So let's go ahead and multiply out even more. We're left with a 2x squared minus a 3x plus a 2x minus a 3 plus a 10x, and that's going to be equal to 2x squared plus a 2x. So reducing all of this down, we will get a 9x minus a 3, and that's going to be equal to 2x, and we can go ahead and get like terms. So subtract your 9x, and you're left with a negative 3 is equal to a negative 7x, which will get you x is equal to a positive 3/7. So we're not done yet. We do need a check. Just check to make sure. 3/7 is not equal to a negative 1, which would make the bottoms 0, so we're actually good to go, and that'll be our solution. X is equal to 3/7. Our next example here, we want to go ahead and solve x divided by x minus 5 plus 5, and that's going to be equal to 5 divided by x minus 5. So first things first, find your least common denominator, which will be an x minus 5 for us, and set that equal to 0 to figure out what your excluded solutions are. So for us, we do not want x to be equal to 5 because that would result in a bottom of 0. So now that we have our least common denominator, we can go ahead and multiply all the tops and see what will cancel out. So we'll go ahead and take x minus 5 and multiply it by all of the tops. And then we'll have an x minus 5 here, plus, and then x minus 5 times 5, and that's going to be equal to x minus 5 times 5 divided by x minus 5. So now go through and see what you can cancel out. For us, x minus 5s are going to cancel out there, and then the x minus 5s will cancel out from here. So now reduce it. You'll have an x plus 5x minus 25, and you'll set all of that equal to 5. So go ahead and solve for x. We will have a 6x is equal to, and I'll just add this 25 over to the right hand side, so that'll be a 30, and x is equal to 5. And again, we're not done here. We want to go ahead and check to see x is equal to 5, and that is what we did not want. We did not want it to be a 5 because this will make the bottom a 0. So what we can go ahead and say is that this is no solution because we have an excluded solution. Next, we'll look at solving rational equations that lead to some quadratic equations. Again, we'll go ahead and check for our excluded solutions here. So our bottom, if you notice, our least common denominator will be x squared minus 3x, and we'll set that equal to 0. So this will reduce to x minus 3, and we can set x is equal to 0, and then we can set x minus 3 is equal to 0, or x equals 3. So we don't want x to be equal to 0, and we don't want x to be equal to 3. So with that in mind, let's go ahead and solve our equations with our least common denominator and multiply it over in the tops. So we'll be left with x times x minus 3 multiplied by our x minus 5 divided by x minus 3, and then we'll go ahead and add x times x minus 3 times the 1 here, and then divide by x, and we'll set that equal to x times x minus 3 multiplied by 7 divided by, and remember, x squared minus 3x is just x times x minus 3. So let's figure out what will cancel out here. X minus 3's, the x's, and then the x minus 3's over here. So reducing this, we are left with x times x minus 5, and then plus x minus 3, and this is going to be equal to negative 7. So let's simplify just a tiny bit. X squared minus 5x plus x minus 3 is all equal to negative 7, and we can get this into a quadratic equation. So this will leave us with x squared minus 4x plus 4 is equal to 0. So we have a quadratic equation here, and let's just see if we can factor it out. So we want two numbers that multiply to 4, and then when added or subtracted gets us a negative 4. So two numbers that come to mind would be a negative 2 and a negative 2. Okay, so negative 2 and negative 2, that would be x minus 2 is equal to 0, and then it's just the same thing. X minus 2 equals 0. So x is equal to 2. Again, you're not done here. Go back up, check to make sure. So in our case, we didn't want it to be equal to 0 or 3. So we are good to go, and we can go ahead and say that x is equal to 2 will be a solution. Peter and Paul are shoveling snow in their driveway, and Peter can shovel the drive in 5 hours, and Paul can shovel the drive in 4 hours. How long would it take both of them to shovel the drive together? So just a few equations here. Rate of work is equal to 1 divided by time. And we also know that the amount of work completed is going to be equal to the rate of work times the amount of work. So let's go ahead and write out what we know. In our case, we have Peter and Paul. So we know that Peter, it says, can shovel in 5 hours, and it says Paul can shovel in 4 hours. So let's go ahead and write that down. Peter is equal to 5 hours, and then Paul, it said, was equal to 4 hours. Using our rate of work right here, we know that we can convert these. So let's see. Peter, and I'll abbreviate rate of work by row, is equal to 1 divided by 5, and then x will represent our number of potential time, and then Paul will be equal to 1 divided by 4x. Okay, so we want to figure out the amount of work completed, and we can go ahead and use this second equation given to us, the amount of work completed. So let's go ahead and plug these in. We want a full job completed, so we'll say 1 is equal to 1/5x plus 1/4, and go ahead and try to solve for x. So let's go ahead and see what this will be. We can say 1 is going to be equal to, and we can pull out an x. So 1/5 plus 1/4 times x. And then we want to go ahead and try to get some sort of common bottom here. So we'll say 20 for the bottom. So the first one we need to multiply by 4. And then the second one we need to multiply by 5. And this will get us 1 is equal to 9 divided by 20x. And then we want to go ahead and solve for x. So divide by 9/20 on both sides, and you're left with x is equal to 20 divided by 9, or 2 2/9 hours. Next, we'll look at solving an equation involving radicals. So we have 4 steps here. First, we want to isolate our radical onto one side of the equation. Next, we raise each side of the equation to a power that is the same as the index of the radical. 3, we solve the equation. And then 4, we want to check each proposed solution in the original equation. So with our equation here, we want to solve x minus the square root of 4x plus 12, and that's all equal to 0. So first step, we want to isolate the radical on one side of our equation. So let's go ahead and isolate our radical. In order to do that, we can go ahead and add this 4x minus or plus 12 over to the right hand side. Okay, so we are left with an x is equal to the square root of 4x plus 12, and now it's isolated. So what does step 2 say? Raise each side of the equation to a power that is the same as the index of the radical. So one thing is the square root, we actually need to raise it to the second power in order to undo it. So we're left with x squared is equal to 4x plus 12. And now this looks like it's a form that we can easily solve. So let's go ahead and get this back, and we'll go ahead and get the 4x and the 12 over to the left hand side. Okay, and now we want to go ahead and factor this out. So we want two numbers that multiply to negative 12 or added and subtracted gets us negative 4. This will be a negative 6 and a positive 2. And then we can go ahead and have our two proposed solutions. So x minus 6 is equal to 0, and x plus 2 is equal to 0, or x equals 6, and x is equal to negative 2. Now, our last step is to check each proposed solution back in our original equation to see if it actually makes any sense. So let's go ahead and try this 6 and this negative 2. So 6 minus the square root of 4 times 6 plus 12, and we want to see if that's equal to 0. This will get us 6 minus the square root of 36, which is just 6 minus 6 equal to 0. That makes sense. So we can go ahead and highlight our x is equal to 6. Let's try our negative 2. Negative 2 minus the square root of 4 times negative 2 plus 12, and that's going to be equal to 0. Negative 2 minus the square root of 4 equal to 0, or negative 2 minus 2 equal to 0, which is negative 4 is equal to 0. That does not make sense, so our x is equal to 6 is our only solution here. Let's look at solving equations containing two radicals. So the first thing we want to do is go ahead and try to get rid of our radicals here, and we can do that by isolating one of the radicals onto one of the sides. So go ahead and add your x plus 4, the square root of that, over to your right hand side. So you're left with a 3x plus 1, and that's going to be equal to 1 plus the square root of x plus 4, and then we're going to go ahead and square that. Now this will be 3x plus 1, and that's going to be equal to, and really this is 1 plus the square root of x plus 4 times 1 plus the square root of x plus 4, and you can go ahead and multiply these out. So we will be left with a 3x plus 1 is equal to 1 plus 2 times the square root of x plus 4 plus, and then x plus 4. Alright, and then go ahead and see if you can get one of the radicals over to another side again. So we're left with a 2x minus 4 and this is going to be equal to a 2 times the square root of x plus 4. So we can go ahead and square our right hand side and square our left hand side and see if we can further simplify. So this will be 2x minus 4 squared is equal to, and then this is essentially a 2 squared and then the square root of x plus 4 squared. So this will be a 2 squared, and then this will be an x plus 4. Go ahead and see if you can simplify that just a little bit further. So it'll be a lot of multiplication here. Oh, we need this. You're left with an x squared, or 4x squared minus 8x plus 16. And this is going to be equal to 4 plus 4x plus 16. So further reducing, you're left with a 4x squared minus 20x, and that's going to be all equal to 0. And now we can pull out a 4x, and we're left with 4x times x minus 5, and that's going to be equal to 0. So our proposed solutions, we have 4x is equal to 0, and we have x minus 5 is equal to 0. So we have x equals 0, and we have x is equal to 5, and we need to go ahead and plug these back in to our original equation and see if it makes sense. So we will have a 3x plus 1 minus the square root of x plus 4, all equal to 1 as our original equation. Try 0 and 5 in both of these to see if they make sense. Let's try 0 first. This will give us a 1 minus 2 is equal to 1, or negative 1 is equal to 1. And that doesn't make sense, so we can go ahead and exclude this x is equal to 0 as one of the solutions, and we can try the 5. Trying the 5, we have a 3 times a 5 plus 1 minus the square root of 5 plus 4, and that's going to be equal to 1. we have a square root of 16 minus the square root of 9 equal to 1. So that's a 4 minus 3 equal 1, or 1 is equal to 1, which checks out. So we know that x is equal to 5 is going to be one of our solutions here. Next, we'll look at solving an equation containing a radical or a cubed root. So we want to solve the cubed root of 5x squared minus 12x plus 6, and then we want to subtract the cube root of x, all equal to 0. First things first, go ahead and isolate one of your radicals. So let's go ahead and add the cubed root of x over to your right hand side. We're left with the cubed root of 5x squared minus 12x plus 6, and that's going to be all equal to the cubed root of x. So in order to undo the cubed root, we can go ahead and raise both sides to the third power, and we're left with 5x squared minus 12x plus 6 is equal to x. Okay, and then go ahead and get all of your items over to your left hand side. So subtract an x, and you are left with 5x squared minus 13x plus 6, all equal to a 0. And we can go ahead and try to solve for x. So let's go ahead and factor this out. I'm going to multiply the 5 times the 6 here to give us a 30. So we want two numbers that multiply to 30, and then when added or subtracted together gets us this negative 13. So that will be a negative 10, and that will be a negative 3. See if you can further reduce here. We can reduce the 5x minus 10 to x minus 2 by pulling out a 5. And we can't do anything with the 5x minus 3, so we'll leave it as is. So our proposed solutions, x minus 2 equals 0, and then 5x minus 3 is equal to 0, or x equals 2, and x is equal to 3/5. So you're not done. Go ahead and check these in your original equation to see if they make sense to include them as your final solutions. So first we'll go ahead and check the 2. Plug this back into your original equation here. So you have the cubed root of 5 times 2 squared minus 12 times 2 plus 6 minus the cubed root of 2, all equal to 0. And this will get you the cubed root of 2 minus, let's see, cube root this will get you the cubed root of 2 minus the cubed root of 2, all equal to 0. So the cubed root of 2 minus the cubed root of 2 is equal to 0. So we will have 0 is equal to 0, which makes sense. So we will keep the x is equal to 2. Let's go ahead and try our 3/5 into our original equation and see if that one makes sense as well. So we will have the cubed root of 5 times 3/5 squared minus 12 times 3/5, and then plus 6, minus the cubed root of 3/5, and this is going to be all equal to 0. So let's go ahead and see what this gives us. We will have the cubed root of, and then 5 times 3/5, 3/5, so then a 5 will cancel out, minus a 36 divided by 5, and then we'll go ahead and add the 6. This is equal to 0. And then the final thing this will get us, I'm just going to go ahead and reduce it real quick, it will be the cubed root of 3/5 minus the cubed root of 3/5. All equal to 0, so 0 equals 0. So that is another solution as well. So our final solution set is going to be 3/5 and 2. Next, let's look at solving equations with rational exponents. So we're given x to the 3 divided by 2 is equal to 216. So in order to get rid of this 3 divided by 2 power, we want to go ahead and take both sides and raise that to the 2/3. So this will give us x is equal to, and what this is looking like is going to be the cubed root of 216 raised to the second power, or x is equal to 6 squared, or x equals 36. So now that we have x is equal to 36, let's go ahead and plug that back into the original equation and make sure it makes sense. So 36 to the 3/2 is equal to 216, or the cubed root, or the square root of 36 to the 3rd power. And that's going to be equal to 216. So then we have 6 cubed is equal to 216, which is 216 is equal to 216. We can go ahead and check that one. And then let's go ahead and look at our second example here. So x plus 7 raised to the 2/5 is equal to 4. Again, we'll go ahead and take this one and raise it to the 5/2 on both sides. So this will leave us with x plus 7 is equal to the square root of 4 raised to the 5th power. So this is x plus 7 is equal to 2 to the 5th, or x plus 7 is equal to 32. And then go ahead and subtract your 7, or x is equal to 25. Finally, go ahead and plug that 25 back into the original equation and see if it makes sense. So this will give us a 25 plus 7 raised to the 2/5 and equal to 4. So this will be a 32 raised to the 2/5 equal 4, or the 5th root of 32 squared is equal to 4. So this really is just going to be equal 4 is equal to 4, which makes sense, and we can go ahead and check that x is equal to 5 is one of our solutions.